In today's video, I'm going to show you how to create such an interactive map where if you hover over a region, a tooltip comes up and shows you the name of that region and also the state of that region. Here we focus on Germany and the German states and regions, but it is really easy to take the steps that I'm showing you and do the same thing for other countries in the European Union. Basically, you just need 5 steps to create this chart. First, you're going to need the geographic data. This means that you need the coordinates of the polygons that form the regions and states. And once you have the data, you can very easily create a static ggplot from that with more or less one line of code. And then you can throw the ggref package on top of that to turn the ggplot interactive. And once you do that, you have a basic interactive map of the country that you want to create a chart for. And if you want to make this even better, you can merge state and district level geometric data with the SF package to make your tooltip more informative by also showing the state and the region name. And once you have that, the rest is just polishing with nicer colors and a couple of stylings. So this is what we're going to do today. Let's dive in. In my Quarto file, I've already put in a code chunk that loads 2 packages. One is the tidyverse, which is fairly obvious why it is there, namely for data wrangling and the plotting part, but there's also this package called gisco_r that is in there. And that package is crucial for what we want to do because it gives us all the data we need. You see, once we have that package, we can use the gisco_getNuts function. And I know this function sounds weird, but I'll explain in a second why it is named like that and all of the arguments that we need to make this function work. For now, let's just throw in our first argument, which is the country that we want, and in this case we want to get the geographic data for Germany. And if you execute it like this, you get an output already. And if you make this into a tibble, then you get a nicer format. And there you will see that the column names are not really nice for programming because they use all caps. So that's why I usually throw janitor clean names on top of this. And that way I have all lower caps, which I think is nicer for programming. In any case, you now see a column that is called level code. And there you see that you have levels 0 and 1 already. But if you throw this to count and throw in the level code, you will see that there are actually multiple levels, namely 0, 1, 2, and 3. And if you know a bit about Germany, then you will probably realize that the names here correspond to different administration regions. So basically Deutschland, that's all of Germany. Then at level 1, there are the states, Bayern, Berlin, Brandenburg, and so on. And then you can see in the counts that you get even more rows for things which correspond to higher level codes. So here you can understand the codes as the higher the number, the smaller the region, and level 0 corresponds to all of Germany, level 1 to the states, and so on. And level 3 is the smallest unit that we have. And this is the one we're going to need for our plot. And these levels are called nuts level, so hence the name gisco_getNuts, because it gives you all the information on all of the nuts levels. And the nice thing about this is that this data set contains the geometry that we need later on. So if we want to get the geometries for other levels or for only the regions, we can specify the nuts level. In this case, we want to have level 3. But as with all administrative things, these things often change in tiny ways. So this is why this package also allows you to specify a year to get the exact regions for a specific year. And if you do that, then you see that your data set only has level 3s in there. But in principle, it still looks exactly the same. But again, in case you know Germany, you'll realize that these things correspond to smaller regions within Germany. So let's save this into a dataset called Germany districts. And with this dataset, we can already create the ggplot. So all we have to do for that is to create a new code chunk, take this dataset, and then pass it to ggplot, and then add a GMSF layer to it, which is the layer that handles all of the spatial stuff. And then of course you need the parentheses here. And if you execute the code chunk like this, it will complain that there are no aesthetics yet. So this is why you throw into the aesthetics, you throw in the geometry, and in there you can specify that you want to use the geometry column from our data set. And once you have that, you can see here that you get a map of Germany. But with maps, it's crucial to understand that the way the map looks depends on the so-called projection that you use. You see, what we try to do is to print a 3-dimensional thing onto a 2-dimensional piece of paper, or onto a 2-dimensional screen in this case. And there are a couple of projections, and depending on the projection that you want to use, the map looks slightly different. And the reason for that is because the geometric data that describes the polygons that we see in the map right now, they are slightly bit different. And to determine what kind of projection you want, you can specify the EPSG code, which is the code for the projection, and then use that inside of your Gisco function. And if you re-execute everything, then things look a little bit different. So in case you're trying this at home and wondering, why does my map look a little bit different than what I'm used to from maps typically, then the reason probably is that you might need to use a different projection here. Alright, cool. We do have the map with the regions now, but it would also be good to see the state borders. And for that, we need to get the geography of the state borders. So let's copy this part here, throw this in there, and then let's call this dataset Germany states and use nuts level 1, I believe. Let's check, let's execute all of this and have a look at the dataset. And yeah, these are the state regions. So nuts level 1 is for the state. In case you want to try this for a different country from the European Union, you will have to figure out what nuts level you need, because in every country, these administrative regions are kind of structured differently. So what corresponds to state level in Germany, nuts level 1, might be a little bit different for some other country. So just so you're aware of that, these nuts level don't necessarily translate perfectly to other countries. In any case, now that we do have the data, we can throw this into our plot. All we have to do is to throw in another GMSF layer, but in that layer, use a different data set, namely the one for the states. And then since that data set also has the geometry column, we don't actually need to describe our aesthetics, but we can in case we want to make states be colored differently. And that's exactly what we want to do. So let's throw in this aesthetics and set the fill to the nuts name, which corresponds to just the name of the state. And then we can also set things like the outline color or the line width of the outline. And if we execute this, we see that we do get a legend, but we still see mostly gray here. And you can probably guess why this is happening. Namely, we plot the state geometries on top of that. So basically all the colored state regions are behind the gray regions. To avoid that, we can just set the fill aesthetic of those regions to NA to make them transparent. And while we're in that layer, we can also make the outline black and the line width a little bit smaller. And now if we execute this, everything looks exactly like we want. Cool, we have a nice map of Germany already, but we want to make it interactive. And for that, we can use one of my favorite packages inside of the GG Ecoverse, and that is ggref. And with this package, it's really easy to turn any GG plot into an interactive plot. You see, all you have to do is to take the layer that you want to make interactive. In this case, we mean the layer that contains the smaller regions. And since we want to make those interactive, we just make this into an interactive layer. And then all we have to do is to specify the ggref specific aesthetics that this package needs. In this case, the aesthetics are data ID and tooltip. I don't want to go into too many details here because I do have a video on just ggref that goes through all of these things in detail, and you should check that video out after this one. But the idea here is that we need to map things to either the data ID or to the tooltip to tell this layer what should be shown in the tooltip and also which things should be grouped together in the hover animation. Here I'm mapping this to the IDs of each region. But you could also think of mapping this to the state name of each region. So that way, when you hover over a specific region, that whole state is highlighted. But again, more details are available in my ggref video. For now, let us just execute all of this. And we see that, well, if I hover over this, nothing really changes. And the reason for that is particular to ggref, because there you have to save the object. You have to save the plot into a variable. And then with the gref function, you can render that object by sticking the plot into the gg object argument of the gref function. And now if you execute this, you will see that we don't look at the plots window anymore, but in the viewer window, which allows for interactive things. And now you see that as I hover over regions, we see the region names. And to make all of this nicer, we should probably throw away the theme so that we use theme void instead of a grid here, because for the map we don't really need the coordinate numbers or whatever these numbers are. And also we don't need a legend for this. So let's get rid of all of that. And now we have an interactive chart that shows us just Germany. We do have a nice map now, and now let's work on improving that. Here, what I want to add to this chart is that in the tooltip, I don't only want to see the region name, but also the state name that this corresponds to. Unfortunately, our data set, the one Germany districts, if we look into this, then there isn't really a column that has that information for us. There's nothing that says state or anything like that. So this is why we have to get a little bit creative in figuring out how to get the state names into this data set. And this is where the SF package comes in, because it allows us to do spatial calculations on the polygons that we have in this column, in the geometry column, and also in the data set for the states. There's also a geometry column in there. So really all we have to figure out is whether the polygon of a region is within the polygon of a state. And that way we could figure out which state a region is in. But before we do that, let me remind you to hit that like button to tell me that you do enjoy this video. And if you really want to make my day, check out my data visualization course, which teaches you everything you need to know about data visualization with R. More specifically, it will teach you the most fundamental data viz principles and how to implement them in ggplot, and it will show you tons of step-by-step tutorial on how to create elaborate charts. So with that said, let's head back to the video. As I've said, we need to do a little bit of data wrangling with these two data sets here, and we need to use the SF package for that. So let's make a bit of room here in that code chunk. So now let's go through the calculation step by step. Let's take the states data set. In there, we do have, well, the states data that we're already used to. Let's minimize this so that we have a bit more room. And from there, we can grab the geometry column. If we look into this, we see that we have a bunch of polygons and multi-polygons. In any case, we have a lot of geometric objects. And what we can do with that is to extract, let's say, the first one. With that, we have a polygon with a whole bunch of coordinates that make up this polygon. And what we can do now is to take another polygon from the Germany regions data set and compare these two. And what we need for that is the stWithin function. And in there we can use, well, this one polygon, and we need to get another polygon from the districts data. And if we execute this, we see that we get an error because I probably didn't load the SF package. And now if we do that, we see that it returned empty because that geometry isn't contained within the other geometry. And what we can do here is to pass this to as logical, and this will give us an NA because there isn't a true or false in there. So what we have to do now is to iterate over all the entries and not just the first one of the geometries in Germany districts and Germany states, and compare all of them one by one. And once we do that, we can extract all of the things where this calculation returns true and not NA, and that way we know that the district and the state that we used are actually within each other. And to do so, we can take this part here and wrap it into map logical, and in there we want to iterate over the geometry in the states, and then we have to write an anonymous function that uses basically the calculation we have just done. And since we always use the states here, we have to replace the states here with y. And now that I see it, we actually have to check whether the district is inside of the state and not the other way around. So that's why we flip this thing here. And if we execute this, we do get an array where we see that there is one true and the rest are all NAs. And we can check at which position we get this true with the which function. And with that, we see that this particular district, the first one that we picked, is in the 13th state. So whatever is at the 13th position of this vector. And now all that's left to do is to wrap this part into another loop to replace this part here, not with some fixed district, but iterate through all of the districts. So basically, we can indent this here and throw in another map function to iterate over all of the districts here. And then in there we use another anonymous function, and this function is used to iterate over the districts in that function step. And now if we close all the brackets and parentheses, we see that this gives us a vector telling us in which state each region is in. But of course, these are only the state numbers. But once we have that number, we can easily extract the state name. So let's save this into a variable. Let's call it state numbers. And then we just have to take our data set with the districts, add another column to this that we call state, and we fill this with the with the entries from the states dataset that are in the nuts name column, and we throw in the state numbers in there. And that way we have to actually save the other variable and then compute this. We do get another variable called state, just to make sure that it's correct. Let's select only the nuts name of that dataset and the new column state. And we see here that for each region, the state was filled. So let's get rid of this subsetting here and throw this into a new variable. And now inside of our gref call, we can use this dataset instead of the previous districts dataset. Of course, at this point, nothing changes. Everything still shows the regular tooltips that we've seen before, but we can now remove this part here and instead use the glue function to assemble a string. And in this case, we can throw in the nuts name again, but we of course need to use the brackets. And then we can throw in a line break, make sure that it's an HTML line break, and then we can throw in the things that are in this state column. And with that, if we re-execute everything, we see now that we do have the region name and the state name in there now. Nice. With that, we have a nice map that already has the basics and all of the information that we want to have. Now it's time to make it look a little bit nicer. And there are two things I want to do here. Namely, I want to make sure that the tooltip label here uses CSS notation so that we do use nicer fonts and different font sizes and so on. And also I want to make sure that the default colors here are not used, but instead some nicer looking colors. And the color part is really easy to achieve. All you have to do is to throw in a scale fill manual layer to change the colors for the fill aesthetic. And in there you have to specify values for the 16 states. And I just went online and looked for a nice color palette that has 16 distinct colors. And I copied the hex code into this here. And if you execute this, you immediately see that you do have nicer colors now. As for using nicer names in this part here, let us actually write a function for this. Let's throw in a bit of space here. And there we can define a function. Let's call it very generic. Let's call it make nice label. And for that function, we need two arguments, namely the nuts name and the state name. And in the function body, we now have to define how we want to use HTML and CSS notation to make the things look nice. And there we first work on the nuts name, and we use the HTML tools package to create a span tag, which is an inline text. And in there we just have to throw in the nuts name and then set the style via the CSS function. And there we can use things like the font weight 600, which is bold. We want to use a different font and we want to use a different font size. And by the same logic, we can do the same thing for the state. We save a new state label. In there we use the state and not the nuts name. And as for the CSS styles, we basically do the same font family and a smaller font, but no bold font. And once we have these two variables, we can stick them together using the glue function again to have them on top of each other by adding a line break to this. If you are not familiar with HTML and CSS, this can feel weird and you might not know what exactly is going on here. I do hope that it is possible to follow along here, at least to get the gist of it. And if you want to get the full details, I actually have a full web development for R video series, and in particular a video about the HTML tools package that shows you how you can use this package to create nice HTML and CSS code from within R. And this can come handy in situations like these, where we fundamentally have to work with HTML and CSS to make the labels look nice in our interactive chart. In any case, we do have a function now that can turn a nuts name, a region name basically, and a state name into a nice HTML and CSS label. And to actually apply this function, we have to iterate through our data set here. So what we have to do is to throw in a mutate call, and in there we want to specify a new column called nice label. And we create this by iterating over the nuts name and the state column, and we stick the things that are in these two columns into the make nice label function. And when we have that label inside of our data set, we can just replace our previous label with the nice label. If we re-render everything, then we see that we do have nicer tooltips. And to round things off, I would like that the hover animation does not turn the region orange, but into a more subtle black. I feel like the orange doesn't work very well with most of the colors here. And the way to do that is to modify things in the gref call. So let's make some room here. And in there, we can specify options for how things are supposed to behave via a list of options. And that list of options can be filled with specific option functions from the gref package. And here we want to modify how things should behave as we hover over things. And there we have to specify the CSS code that is applied on the thing as we hover over it. And once again, ggref has a helper function to apply CSS instructions to specific geometries. Here we want to have in general no styling at all. So if we hover over something, nothing happens. But on the area geometries, I'd like to see that the outline is black and also the fill color of that specific region becomes black as well. Again, all of these things are explained in more detail in my ggref video and in my HTML tools video. But in any case, you have made it through all of the hard part, and now if we render this for the final time, you do see that we have a nice hover animation and the corresponding region turns black. So with that, we have learned how to create a nice interactive map all from within R using ggplot. And if you want to learn more about ggplot, check out my data visualization course where I teach you how to create insightful data visualization using ggplot. You don't have to learn a bazillion data visualization principles, you just need to learn the fundamentals and learn how to implement them with R. And that is exactly what I'm showing you in my video course. And if you're interested in that, you can follow the link that is popping up right now. So thank you for watching, and I will see you next time.